and we have an amazing program, some great plenary speakers, an NIH collaboratory workshop, and 5 ancillary meetings. So we're making the conference as interactive as possible for a virtual conference. And we really hope to literally see you there, because I promise at some point in time, I will have my camera on and people will actually be able to see what I look like. So, to get started, we're really excited about the SDRF presentation today. Maccabi Institute is a member of the HCSRN, a longstanding member, and is very engaged in a variety of different work across the network. Gabby Chodik today will be presenting along with the MDClone team, talking about the work that he is doing and how he's used MDClone to accomplish that work. But I'd love to take a moment to introduce Kevin Gibson from MDClone, who is going to introduce the rest of the group today. We started chatting months ago, and MDClone is in a really exciting new entry into the world of data, of healthcare data. Kevin, in particular, is the director of MDClone's global partnerships. He manages new partnerships for MDClone internationally, as well as in the Midwest and across the Northwest. I didn't know this about Kevin, but he is a biomedical engineer with 20 years of analytics and healthcare IT experience. He's also led teams at Optum, Siemens, and Pyxis, and a high acuity EMR provider as well. So thank you everyone for joining us today. I believe that we take a break next month for SDRF, and then we'll start back up in June. The HCSRN spring newsletter is coming out next week. We'll have more detail about the conference and also a few other events on the calendar for both May and June. So look for that in your inbox later in the week. And with that, I'm going to hand it over to Kevin and to Gabby and to the rest of the folks who'll be presenting today.
Great. Thanks, Jeanette, for the great introduction. Our team is a little bit smaller than expected. Dr. Wartenfeld, our CMO, who is going to be doing the demo today, woke up with a case of the flu, but he has graciously provided us a recording of his demo, so we will be able to continue on. We also have Dr. John Morrow joining from our team. He's our Senior VP and Physician Executive for North America. John is also a practicing OBGYN in New York, and as well as Josh Rubel, our Chief Commercial Officer, is logged in as well from Atlanta. And I have to mirror what you said. We're absolutely delighted to be here with Gabriel Chodik from Maccabi Healthcare in Israel, where it is now, I believe, 11 o'clock at night on a national holiday. So thank you, Gabby, for stepping up. I think many on the call probably know Gabby already, but please introduce yourself, Gabby, and then feel free to jump right in.
Thank you so much for having us today. My name is Gabi Chodik. I'm head of Maccabi Tech. It's the epidemiological research arm of the Maccabi Institute for Research and Innovation. I've been with Maccabi for the last 21 years, and I'm also a full professor at the School of Public Health at the Tel Aviv University. So we thought of since Maccabi is the only non-US organization within HCSRN, we thought of taking advantage of this event and tell you a little bit about the Israeli healthcare system, which becomes very relevant to the rollout of the COVID vaccine that took place over the last 3 months. And then talk about a little bit about the Maccabi and its IT, and then about MDClone and a demo of its platform, and finally about our recent COVID-19 vaccine studies that analyzed the vaccine effectiveness as measured using the Maccabi data. So for those of you who are interested in having more information about our initiatives in big data using Maccabi data, I recommend on this Harvard Business School case study that was published in 2019, and it was recently updated, the Maccabi Tech, the Promise of Israel Healthcare Data. So the institute is organized with 4 different departments. The Maccabi Tech includes both epidemiology and clinical research arm. We also have the innovation and big data arm, and a biobank, which I'll be talking about later on. So every Israeli citizen and resident enjoys a national health insurance since the legislation of the law in 1995. The funding from the national health basket comes from the healthcare tax, which is about 4.8% of the income, where the rest comes from the general taxation money. Every Israeli citizen must choose one of the 4 competing HMOs. Membership is absolutely free, and Maccabi is one of those 4 HMOs. Maccabi cannot bar anyone from joining Maccabi, and patients can move, or members can move freely between HMOs once a year. So essentially, the competition is not over prices or access to care, but it's mostly over quality of care. Overall, Maccabi accounts for about 25%, a little bit more than 25% of the Israeli population. Clalit is the largest HMO, and the 2 smaller ones are Leumit and Mauchelet. In addition, in Israel, we have...
I'm sorry to interrupt, but your slides are not moving forward.
Oh, they are not? Oh,
thank you.
Maybe I should. Can you see it now?
Yes.
Oh, I guess once it's on presentation mode, you don't see it moving. Okay, so I'll start from here. So this is Maccabi, where it accounts for about 25% of the Israeli population. And also we have public hospitals, 45 general hospitals in Israel, which are out of the network. And data has to be shared between all the different players in the system. And this is a major challenge. We also have 13 psychiatric care facilities and over 300 nursing facilities, which is a major issue and challenge in sharing the data of our patients. A bit about Maccabi statistics. With 2.6 million members, we have 9,000 employees and 5,000 physicians. Most of them, 90% of them, are independent physicians. Since membership is totally independent of where you live or where you work, the retention rate is very high. Less than 1% of our members are moving out of Maccabi annually, which allows us to collect information over a very long period of our members. Maccabi owns the Asuta Medical Center, which is the largest private hospital network in Israel, with 13 facilities all across the country. We also own or have contracts with over 700 pharmacies countrywide, and the total income budget of Maccabi is about $4.5 billion a year. So Maccabi is a very centralized organization where all the data from the 5,000 physician offices, nurse stations, image centers, physiotherapy clinics, all hospitals, pharmacies, all are transferred on a daily basis to one server, one center in the Maccabi headquarters in Tel Aviv. There is only one lab that provides service to all 2.6 million members, which makes our life easy when we talk about lab tests, and there is no difference in calibration or methods as we have only one mega lab. And also we have, of course, our members have a direct access to their EMR through their secured website. So for many years, for more than 20 years now, every transaction within Maccabi is computerized. We have a shared EMR where every physician can log into every member's EMR from anywhere in the world. All lab tests are computerized. Uh, we have digital prescriptions, e-consultation. A physician can consult with other physician on a shared EMR even during visits. And of course, a very well-developed alerts and reminders within the EMR, and a physician portal where a physician can look at their quality indices in comparison to other physician in the district and physician on a national level. And this alone really boosted quality of care because physicians are very competitive by nature. On top of the crude data, we have developed over the years a wide range of disease registries. These are based on diagnosis, medications, lab tests, hospital discharge, procedure, etc., and validated against the primary physician of the patient who knows the patient best. So we believe it's of a very high validity. For some of the registries, such as the cancer registry, we cross-link the data with the National Cancer Registry. We also capture information on imaging. These are the amount of images taking place in Maccabi annually. We talk about almost 200 CTs, 800,000 X-rays, over 100,000 MRIs, etc. And everything is kept and stored either in Maccabi or in one of our hospitals in Suta. Overall, I think the data in Maccabi is about 1 petabyte of data, which is quite a large amount. I mentioned our mega lab. So, sorry. In the mega lab, we have about 100,000 tests a day that belong to almost 15,000 patients. And due to this important resource, we have used the lab test as a key for personalized medicine, which is strategically a very important avenue that Maccabi develops over the years. And on top of the digital information that we have and the phenotype stored in the EMR, we also developing the biologic, the genetic vertical of information. So in 2017, we launched the TIPA Biobank, the Maccabi Biobank, where every patient that opts in signs a very wide informed consent. And from that day and on, every time one of our members is having a blood test or urine test, one tube is kept for research. So we have multiple tubes per patient over time. And I should acknowledge the great help of our colleagues in Geisinger MyCode initiative that help us a lot with good advice in the early days of the TIPA Biobank. So as a learning organization, Maccabi sees a great value in making its data accessible to researchers. And and 2 years ago, we opened the virtual research room where researchers can log into the server and work either on de-identified data, true data, or synthetic data layers. And currently we have many researchers both in Israel and in the US who work on Maccabi data for their research. But as time went by, we learned that we have several barriers in making our data accessible to either mid-level executives or to researchers. In order to make the data cut, you would need to know a different variety of coding methods that may include ICD-9, ICD-10, ICD-0, and Y codes that were developed internally in Maccabi. We also noted that there are many challenges for these researchers to use SQL and conduct the data queries as required for the research. We have several issues of securing data, and in the previous slide, there were we mentioned 2 layers of anonymization, but yet there are always a risk of data privacy in sharing such a huge amount of data. And on top of the privacy, we also have an issue of organizational data asset that Maccabi is unwilling to expose, such as a market share of different medications within the class. So there are some challenges in this aspect. We also have some difficulties in getting a proper and engaging visualization of the data, even once the data cuts are done. Making the data into information, sometimes it's challenging. And additional barrier is sharing data between organizations. I mentioned earlier that we have many players in the system, and transferring data between different hospitals and different HMOs sometimes becomes a nightmare when we talk about different coding methods and different types of information. And I think that MDClone provides a very efficient and very successful solution for most, if not all, of those barriers. So, Kevin, maybe you want to take the stage?
Sure. Thanks, Gabby. Yeah, I very briefly will introduce MDClone and our technology to set the stage for what comes next. But MDClone was, in fact, founded to address some of the very barriers that Gabby just highlighted. Specifically, we set out to solve 3 long-standing problems in healthcare. The first of which is the long delays associated with mediated data analysis. Everywhere we go, we meet researchers, clinicians, executives that are wholly dependent on analyst teams to build cohorts and query data for them. And in most cases, this is taking many, many months, which is, obviously far from ideal. The second is the well-founded fears around patient privacy and data security, which not only limits access to data, but adds even more delays. And the third, I think, is the challenge of how to operationalize the insights obtained from data in a more streamlined way. And in other words, how do we translate all this new knowledge into improved outcomes and or more efficient processes? Next slide, please. Oh, I'm sorry. Can you go back one, Gabby? I didn't mean to tell you to go ahead there. So we actually address these challenges with 3 things: self-serve analytics, synthetic data, and a platform that enables continuous learning. And by self-serve analytics, when we say self-serve analytics, we mean putting data exploration directly into the hands of researchers and end users, and eliminating really the need for analyst help. The synthetic data piece enables collaboration and innovation in new ways, even across or outside of your organization, without the fear of compromising real patients in the process. And the platform we're going to show you today itself is called ADAMS, which stands for Ask, Discover, Act, Measure, and Share. Next slide, please. So this is a process where end users can ask questions, build cohorts, explore data, act on insights, measure results, and even share insights and practices with others, all from the same platform. And a single platform is really helpful because this process is never as simple as the upper diagram suggests. It's not a circular linear process. In reality, it's often a lot of back and forth, which in today's world means going back to the analyst team for at least the cohort building and the analysis part of this. With MDClone, users do this on their own without help from IT, which we see over and over again literally reduces some of these data projects that once took 8 months or more down to a few days or weeks. Next slide. Oh, so I think we actually might skip this one in the interest of time, other than to say, you know, we're very fortunate to have added organizations last year, like the NIH, the VA, Jefferson, and several others to the MDClone family, despite everyone sort of being paralyzed by the effects of the global pandemic. We've been growing rapidly, and rather than go through all of the various new additions, I think we'll jump right along here because we're running a little short on time, I think. So what is it exactly that MDClone does? How is it possible to shrink a 9-month data project into a few days? Well, the simplest answer is that analysts are required today because the data is so complex, and it's literally locked away, except for those that have SQL skills and knowledge of data structure. For anyone other than those types of folks, the data is locked away. And so MDClone removes this barrier. Next slide. And we do this by creating a data lake that contains all of the data that an organization needs or requests. And there is no limit to the number of data sources that we can pull in. There's no limit to the amount of data or the type of data we pull in. It can be structured or unstructured data. And once we've populated the data lake, the next thing that we do is we reorganize that data longitudinally so that the data elements now simply become events on individual patient timelines. So if you think about this as kind of a giant spreadsheet where the rows correspond to individual patients in the system and the columns correspond to the time-stamped clinical events of a patient's life, that's kind of what this looks like. So next slide. So this reorganization of the data allows us to then overlay a very simple query tool, which we're about to show, that enables any user to ask any question of the data in terms that are familiar to them. And just to know, as when we're watching this, the demo, something to look for is just how easy it is to go back once a cohort has been defined, to go back and change the query and rebuild the cohort on the fly. It's you know, for someone that's used to the old paradigm, it's quite a change. Next slide. And then we will also show how synthetic data is generated, which at a high level involves taking the underlying statistical properties of a real patient cohort and then reproducing it with fake people that just cannot be re-identified because they never really existed in the first place. Next slide. And this is my last slide. And so finally, you know, the synthetic data capability is really opening a whole new world for a lot of organizations, especially when it comes to innovation and collaboration. The NIH, for example, is using MDClone synthetic data in their N3C COVID research initiative, which I'm sure many of the folks on this call are familiar with. The database there now contains more than 4 million patients from across the country. More than 1 million, I think, of them are COVID positive patients. But there's another example as well, which was the recent formation of a global research network by 14 of our customer partners across the US, as well as in Israel and Canada. And Maccabi, incidentally, is also a member of that global network. So that's kind of a very quick, very high-level overview of MDClone. So with that, Gabby, I'll hand this back, and you can talk about how this is actually working in the real world.
Should I start a demo, or would you like to start a demo?
Didn't you want to, we can do the demo now, or you can review your vaccine studies first. It's up to you.
Why don't we start with the demo, and we'll do the vaccine later on.
Okay, sounds great. And
so do you have we have the link?
Oh, I thought you were going.
Okay, so I'll take the link. Yeah, no, I should have it.
I think you're just sharing the PowerPoint application. You need to, if you wanted to share something else.
We have the demo. Wait a minute, I had it in here. Where is it? Sorry.
I will demonstrate, and we'll start to ask some of our hypothesis questions for this cohort. So let's look at the distribution of the pneumonias over the past couple of years. I will demonstrate the usage of the Adams platform for
Did you see it? Can you see it?
We have.
It's just a black screen right now.
Okay. Hold on.
I can maybe try and share it on my side here.
It should work. Okay. Can you see it now?
There we are. Yes.
Yep. Oh, okay. Sorry. Yeah.
So we don't hear any sound, and I think if there's sound, then when you go to share it, there should be a box that says share audio. There should be a click somewhere.
Ah, okay. Wait a minute.
Where you can
Share
also
audio?
say, yeah. And then we should be able to hear it.
Ah, okay. Just a second. Stop. Share. Wait a minute.
Do you see something there that says share audio or something when you go to share the screen?
I see share.
It looks like you're using the browser base. I don't know if it's possible. You probably need to download the client, but it's okay.
There it is, Gabrielle. It's on the upper left, above the little windows. It says include computer sound. Go down. No, go down.
Okay.
Go down.
Yeah.
Just above the little windows on the left. You see where it says desktop? There's a switch just above it. Below the Adams screen.
Below this here? Wait a minute. Where do you see that?
So click share. Click share in the in your Microsoft Teams toolbar. That one. Stop sharing and then reshare. Do it twice.
Okay.
Now do it again. Now turn on sharing.
Over here.
Click the up. It's an up arrow in a box. It's a funny icon.
Okay.
And now above where it asks you to pick the window that you want to share, there's a little slider that says share computer audio on the left side above the little windows.
I'm
You
sorry.
see it? Do you have it?
No.
You might not. I can't see your screen, so I can't see. But do you see where Microsoft Teams offers you the windows to share?
Yeah.
There should be just above those little mini windows on, maybe it's on the right side on your screen, but on the left on mine, there's a little slider that says share computer audio.
Let's see. Does this work? Can you hear that?
No.
No, maybe we don't need to hear it though. Maybe if we just see it.
No,
Should hear it.
I think it's because you're using the browser version of the Teams instead of the client version of it.
I just don't understand. I don't know. I don't know how to.
Let me see if I can share it from my computer, perhaps. Give me a moment to find it. Okay, I can try to share it from my computer. My internet connection is not the most stable, so that's another issue. But let's see if we can get this going.
Okay, I'm sorry.
No, it's quite all right. Let me just let me see if I can just find. Here we go. Share. Find it. Just give me a moment.
We don't hear anything.
I know. Yeah, I know you don't. I don't know why.
It's okay.
Include computer sound. It's because I'm on headset.
Yes, maybe because you're not using computer sound.
I'm not using the computer sound, so let's see if I can figure all that out. So let me get off of the computer sound.
You can, if you're using the client, you can go to click on 3 dots, then device settings, change the audio device to your computer native ones.
Let's define this project. And let's just look at how many of those do we have.
We can hear it now.
I will demonstrate the usage of
a bit, but yeah, we can hear it.
For hypothesis testing and research. Before I do that, I just say that our customers are using the Adams platform in addition to research, also to run projects for quality improvement, for cost reduction. Many of those projects require, in addition to extracting data and doing discovery, also interventions based on insights that were found and based on opportunities that are being identified throughout the exploration process. And then after those interventions, they also use Adams to measure specific KPIs, which are specifically related to their projects. But in this example, I want to use Adams platform on Maccabi here to explore 2 hypotheses that I have. One is related to the COVID vaccinations. So I want to look at the rate of COVID positive patients after they were vaccinated. The expectation is that those numbers will be very small. So let's look at that. And the other hypothesis is that I have, and again, things that were discussed in the industry, is that throughout the last year during the pandemic, we had a lot less non-COVID infectious diseases due to the lockdowns and mask wearing and all the measures that were taken. So that's something that I also want to prove today, or at least look at some of those numbers. So let's start with the COVID vaccination use case. Let's define this project. And we will start by defining our cohort of interest, which is quite simple here. Our cohort is COVID vaccinations. So all patients who had at least one COVID vaccine. So let's see. So our corona vaccine population, the first vaccine, and let's just look at how many of those do we have. The system grabs in real time the number of patients based on our definition here. So we have 1.4 million patients, more than 1.4 million patients, which is a nice number, very large number. So now let's look at how many do we have with the second vaccine. Let's duplicate the same definition. So we want second vaccine. And we want the first vaccine after the reference event, which is the first. This will give us the second vaccine. And the system will go and show us the percentage in real time. Until this comes up, let's look at the positivity rate after these vaccines. So, positive after first vaccine. Yes. And we want those that the result is positive. The first after the reference event, which was our first vaccine. So let's look at the rate of positivity after the first vaccine. This will come up in a second. And similarly, we want to just duplicate the same definition. So COVID positive after second vaccine. So we want the first after, in this case, not the reference event, but the second COVID vaccine. Only 1% of the patients who had their first vaccines were tested COVID positive after the vaccine, and less than 1% after the second vaccine, which are very, very low numbers that are consistent with what was also reported by the Ministry of Health. So we can further go and analyze the population of the vaccine patients, looking at adverse reactions, which are partially documented here. But we can stop here and move to our second use case. The second use case is about let's define our population here as well. So our cohort will be any patient that had pneumonia in the past years. So let's just search for pneumonia. Let's capture them by diagnosis. And there are many pneumonia diagnoses here in Maccabi, as in the other health system. And I can go and pick each one and select the relevant ones, or leverage the semantic solution that we have here in Adams, which allows us to search for clinical entities with some higher level categories or subcategories. We can search by aliases. So let's just grab all the relevant pneumonia categories here, excluding the congenital, excluding the viral, and excluding pneumonia in other diseases. And let's focus on just the recent years. No need to go a lot back in time, so that the diagnosis start date is after or greater after 2018. Now again, let's look at the size of the population here, which will come up in a few seconds. So 166,000 patients that had a diagnosis of pneumonia in the past 3 years. These include community-acquired pneumonia and also community-acquired pneumonia that was hospitalized eventually. We will differentiate them in a second. Now let's capture the admissions that were maybe related to these pneumonia events. But before that, let's just select what do we want to extract about the diagnosis itself. So obviously the year in which this was documented. So the diagnosis date, but in years, the age of the patients. We don't need a code and the diagnosis source here. So let's look for the relevant admission if there was any. And we want admission events. Admissions, and we want the nearest admission. Again, I can specify the first, the second, the last admission, before, after. I can be very, very specific to define the event, the relevant event on the patient timeline. So here I want the nearest event, to the nearest admission to the reference event, and I want to limit it so that the admission start date is within 7 days before or after the diagnosis. So really capture admissions which are somehow related to this pneumonia. And for the admission, I want maybe just the days from reference at this point. So if you're in this use case, we can maybe answer another question about the same cohort. So, for example, looking at antibiotic choices for these pneumonias, and I want to capture the first antibiotic that was dispensed for these patients after the diagnosis was made. So again, I don't know where these are documented, so I'm just going to search by antibacterials, and I will choose medications that were dispensed, and I want to address these medications by the main group, which is antibacterials for systemic use. And I want the first after the reference event, which is the diagnosis. And here again, I want to limit it to just the first, maybe 7 days. Because there may be some other antibiotic that was given much later. I don't want to capture that. And I want to know the substance of the antibiotic, so I can look at differences over time, maybe, and maybe the dispense date, the days from reference event. Let's pick some demographic parameters like the gender. And I think at this point, this is enough. So we can see that only 9% of patients were admitted over these 3 years. We look at the stratification of these admissions over the years. And out of the total population, about 80% did receive some antibiotics. So on the next page here, which is the summary of what we asked for so far, we will be able to further filter. At this point, before actually being able to extract the data and explore it, the system checks my credentials. If I'm a user that is allowed to see original data, then I will be able to continue my exploration based on the original identified or de-identified cohort, depends on my permissions. But if not, which is the majority of cases, the system will generate synthetic data for me. Now, the generation of the synthetic data is done per each query. So for every time I run the query, I get a new synthetic cohort, but every such cohort that is being synthesized accurately reflects the original statistics of my original cohort, regardless of how many times do I synthesize the cohort. Now, what happens at this point is that the system grabs the original cohort with all the data that we asked for, performs a model building of the original cohort, then discards the original cohort and regenerates a new cohort based on that mathematical model that was created from the original cohort. Now, this new cohort then fully reflects the statistics of the original cohort, but none of the original patients are actually found in the newly created cohort. So there's no chance for any privacy breach of the original cohort. It'll take a few seconds to complete the synthesis. For each synthetic creation, we can also generate a comparison report, which is actually created right now. And this comparison report provides insight to the user about the accuracy or the validity of the synthetic file compared to the original file. And this helps gain some trust and some reassurance that the synthetic file really represents the statistics of the original file. Now, this file can be created for each synthetic generation. It's obviously not mandatory. It's another tool that the system provides to the researcher. Let's examine the comparison report. So first, we get some visibility to how accurately the synthetic data represents the original data, or whether some censoring had to be done. Censoring is a mechanism that is sometimes used on categorical data to prevent privacy breaches. So in this case, no censoring was done. And then we get to see a distribution of the data in each one of the parameters that we extracted, comparing the synthetic distribution to the original one. So you can see that it's really identical, almost identical. So this shows you that on each variable, the distribution is exactly the same as the original. And what we also show is correlation of each parameter to each other parameter. And then we show that correlation for the synthetic data and that correlation for the original data, putting them on this chart. So we can see that all the correlations fall on this diagonal, meaning that the correlation that was found on the original is the same as the correlations that were found on synthetic. So it's a tool that can be used to get visibility on the utility of the synthesized cohort. Now we can go and start or continue with the exploration process. We provide some exploration tools within Adams, but obviously any exploration tool or any a statistical tool can be used on the extracted data. And we'll start to ask some of our hypothesis questions for this cohort. So let's look at the distribution of the pneumonias over the past couple of years. As we started with the first question. So we can see quite a big difference comparing 2020 to 2018 and 2019. So some of the differences were expected. I think this is really interesting here. Almost a third of the number of pneumonias, all the pneumonias in 2020 compared to the previous years. So let's just name it. Years. I can save this this chart for future use. I can accumulate discoveries here. And I can duplicate this and maybe stratify this by gender, see if we have any difference, any gender differences. Probably not, but we can check that quite easily. 2021 is not yet relevant. It's here, but it's less relevant yet. So
I'm not sure what happened there, John, but it's probably for the best because I know we're running short on time here. Gabby, why don't you, I know you wanted to maybe share some results, or Jeanette, what do you suggest? We can certainly field questions afterwards via email or.
Sure. Yeah, so we only have a few minutes left, and I know folks are already heading to other meetings. So my thought was that Gabby could share a bit of his work, and then if folks have questions, they can certainly reach out to Mark or Risa or myself with those questions, and then we can get them over to Gabby or yourself to answer, and then send back out, because I'm sure folks are probably going to have to pop off, right at the top of the hour.
Yes. So apologies for the technical difficulties. So yeah, go ahead, Gabby.
Thank you so much. So as you could see, using MDClone, it would be very easy to pull out the data on those that were vaccinated, and these are the figures for Maccabi. 86% of our members aged 16 and above have been already vaccinated, 93 of those 50 and above. And the metrics for COVID is in line with this high vaccination uptake, a very clear decrement in the risk of COVID-19, both in hospitalization and mortality. And this figure shows you the nice correlation between the increase in the vaccination coverage against the morbidity. And you can see that the younger patients account for a greater proportion of the patients. Now, we looked for assessing the vaccine effectiveness using the data. This is a reminder of the phase 2 of the Pfizer's vaccine, and this is the only vaccine that is being used in Israel. You can see that the first dose didn't have a lot of neutralizing titer. It's only around 12 compared to 140 after the second dose. So we're wondering, what is the vaccine effectiveness of the first dose? And we used this result of the phase 3 trial that shows that within the first 10 days, the vaccine doesn't really do anything. I mean, the cumulative incidence and the placebo arm and the vaccine arm are almost identical. So we used this time as a reference period to assess the vaccine effectiveness later on. We had additional support for this assumption from our recent publication in Nature Medicine that looked at the viral load. And indeed, in the very first days of the first dose, the viral doesn't change among positive cases. So this really reassures that the first few days, the vaccine really doesn't do much, and we can use that as a reference period. So in our first analysis, we used the first 500,000 patients in Maccabi that were vaccinated, and we compared the first 12 weeks to the 12 days that preceded the first 12 days, assuming that we would see a much lower infection rate along the way. So of course we excluded those who had a prior infection and those that just recently joined Maccabi. And this is the result. This is the cumulative incidence of COVID-19 days after the first dose. And unlike in the phase 3 trial, in Maccabi, we saw a much smaller decline that really took place only 18 days after the first dose. And this is also supported by this cumulative incidence figure. The curves really diverge only at day 18 after the first dose, unlike in the phase 3 trial. Overall, we assessed the first vaccine effectiveness at 51%, a very similar study using vaccinated versus non-vaccinated from the Clalit Health HMO showed a very similar result. More recently, we looked at the effectiveness of the second dose using a very similar method. And here we can see that when we compare the risk for a positive result in the first 7 days after the first dose, look at the major decrement in risk as we reach the second dose. And 7 days after the second dose, you can see a 90% reduction in risk. This is based on 1.2 million members. And this is the vaccine effectiveness, both again, infection and symptomatic COVID illness across age, sector, and comorbidity. And in all of them, you can see a very high vaccine effectiveness that for symptomatic COVID reached 94%. A somewhat lower vaccine effectiveness was measured in immunosuppressed patient. Although I shouldn't, this is the last slide, I should say that although the vaccine reduces the risk by 94%, for those that are infected, hospitalization rate and even mortality rate are quite high, and the infection should be taken seriously even among those that were vaccinated with 2 doses. This is hopefully will be published soon. I'll be happy to share the publication as published. So thank you so much.
Thanks, Gabby. And we did have a few folks who asked if you would share your slides. So if you are amenable to doing that, we can post them on the HCSRN website for folks to download. But I know folks are popping off already. That was an amazing presentation. And so we'll be looking for the publication as well. And I also know that some of this work will be presented at the conference, I believe, also. So thank you, everyone, for joining us today. If you do have any questions, please do send those to Risa or Mark or myself. All of our emails are on the HCSRN website, and we'll be sure to reach out to Gabby and the rest of the MDClone team and get responses to your questions back to you as soon as possible. So we really do appreciate everyone joining us today, and we look forward to seeing you at the HCSRN conference May 11th and 12th virtually. So everyone enjoy your afternoon. Thank you so much.
Thank you.
Bye now.